In this video, we are going to discuss about introduction to AI. What is artificial intelligence? Okay, we are trying to make machine to understand or uh, doing things like human being. Here, AI is a study of how to make the computers to do things at which at the moment people are better. Okay, we are trying to make the machine to understand or doing things like a human. This is called artificial intelligence. Definitions of AI. Here, Tom Dean and Matt Ginsberg have given some definitions for AI. Here, Tom has given like artificial intelligence is the design, study, and construction of computer programs that behave intelligently. And Matt Ginsberg has given like artificial intelligence is the enterprise of constructing a physical symbol system that can reliably pass the Turing test. The intelligence that covers the reasoning for the decision taking and learning from the environment, perceiving the environment and solving the problem and linguistic intelligence. This combines intelligence. Here, the difference between intelligence and artificial intelligence is given here. The intelligence is a property or ability attributed to the people, such as to know, to think, talk, to learn, to understand. So it's a combination of knowledge and able to perceive, feel, process, communicate, and learn from the environment. So here simply we can say artificial intelligence is an interdisciplinary field aiming at developing techniques and tools for solving the problem. Our aim is for solving a problem using this AI. What are the AI techniques we have? The AI techniques includes searching, use of knowledge and abstraction. Searching in the sense we are trying to find the best solution for solving some problems. Then this can be solved using the prior knowledge or past history. It's nothing but use of knowledges. And abstraction, the thing is it finds a way of separating important features and the notification from the unimportant ones, which is uh, required to give to the people. Okay, the wrapping that important information in a single unit. So think about abstraction here. And AI techniques that exploit something like the knowledge captures generalizations. It can be understood by the people who must provide it, can easily be modified to correct errors, can be used to integrate many situations even if it is not totally accurate or complete, and it can be used to help overcome its own sheer bulk by helping to narrow the range of possibilities that must usually be considered. Then problem solving with AI, that includes 5 steps. One is defining the problem, analyzing the problem, identification of solutions, choosing the solutions and implementations. So here problems are issues which comes across any system. We need to find the solution for the given problem, maybe in terms of number of steps, and here there are 5 steps given. Then defining a problem, it should be included precisely and it should contain the possible or initial uh, situations, initial and final situations that result in acceptable solutions. Then analyzing the problem, a requirement must be done as some futures can immense impact of resulting solutions. Then identification of solutions, that is generate reasonable amount of solutions to give the solution to the given problem. Then choosing the solutions, we have more solutions, find the best solution among that. Then after finding the best solution, you can try to implement the system. So these are the 5 steps we have in this problem solving in AI. In this again, broad categorization of AI problems be given like structured, unstructured, linear, non-linear. Okay, well structured in the sense it's giving the correct answers. Unstructured somewhat hard to formulate the problems, maybe in ambiguous in nature. The linear problem have clear solutions, but it's not like in the non-linear problems. Then AI model, it covers like Danger introduced May's hypothesis, logic theory, machines, advent of natural language processing and man-machine dialogues. Then formal models proposed to solve the AI problems, human behaviors. So here when it's going to this we have this diagram. In this we have discover and model. We are discovering some relationship, knowledge is here. Then when you are moving towards in the implementation using this AI applications, then complexity is also increased. Again, this AI can be a semiotic or statistical models. Here semiotic model we are going to use some sign process or signification of communications. But here we are representing or formulating the relationship among the statistical techniques. Then data acquisition and learning aspects in AI. Here we have this knowledge discovery, computational learning theory, neural and evolutionary computations, intelligent agents, multi-agent systems, and multi-perspective integrated intelligence. These are the various topics we have in this data acquisition. So how do you collect the information? So how do you go for collecting data set? That include these 5 steps. Then problem solving process. The problem solving process in AI includes identify the problem, explore the problem, create a knowledge base and take the necessary actions to move towards the implementations. Then we have intermediate states and find the goal state, that solution you are reaching. If it is not, then you can go back, problem solve again, repeat the same till you are getting the best solutions. These are the various steps we have in this problem solving process. Here, this problem can be defined using these 5 components. You can say there are 5 components in your problem. One is initial state, that agent or that system it's going to start with. It's called initial state. Then description of possible actions or the operators. Okay, what are the set of actions we are going to start or going to execute it. Then here we have this transition model. Maybe this can be described using this result of start or the current state and what may be the next state A, the success state. Then state space, that includes set of all states feasible from the initial state by any sequence of actions. Here A is actions, may be represented using a graph. The graph we have a path. Okay, sequence of states connected by sequence of actions. You can say path. Then goal test is that determines whether a given state is a goal state or not, whether you are expecting that solution or not. These are various components of the problem. Then the path cast. Okay, if the edges are seen with any cast, then this can be calculated using this path cast. Then for moving from one step to other step, this is a step cast. Then solution to your problem is an action sequence leads from the initial state to the goal state. Okay. Then formulating the problems, that includes choosing the relevant set of states and feasible set of operators for moving from one state to the other state. It's called problem formulations. Then the process of imagining sequence of operators that is applied from the initial state to the goal state is called searching. We can say there are 2 kinds of problems, toy and real world problem. The toy problem is for solving some exercises. It's like game we are solving like chess, 8 queens problem. But real world problem is not like that. It's for we are really carrying about to real time implementation we are moving. Okay, for example, traveling salesman problem. Okay, so these are 2 different kinds of problems we have. Then what are different problem types and characteristics we'll see. Then the problem types may be a deterministic or observable using single state, non-observable may be in the multiple states, non-deterministic or partially observable or unknown state space. We'll see one by one. Deterministic or observable single state problems. Here each state is fully observable and it goes to the one defined state after any actions. If it's a particular state, if you apply any action, it will go to the next state. Definitely. Example, vacuum cleaner with sensor. The vacuum cleaner is going to sense whether there's a dirt in the particular tile. If there's a dirt, that is going to suck that dirt. If there's no dirt, then it will move the next tile. So sensor is used to sense whether there's a dirt in that tile or not. They non-observable. Here the problem solving agent, here agent is nothing but something that pursues the environment and acting accordingly. We will discuss about agent in the separate video. So problem solving agent does not have any information about the state. Here the solution may or may not be reached. Without knowing whether we are moving towards the correct path, it's moving. We are trying to find the solution. Example, vacuum cleaner without sensors. Okay, if it's going to clean, if there's a dirt, okay, it's going to check there's a dirt. Okay, so without sensor, it's going to analyze there's a dirt in that. The third type is non-deterministic or partially observable problem. Here, the effect of action is not clear. Where the perception provides new information about the current state, there we can go for this kind of non-deterministic problems. Here, the vacuum cleaner, and I assume the sensor is also attached to it. Okay, the movement of the particular cleaning will be based on the current perception. These are the various problem types: fully observable, then single agent, multi-agent. Okay, then fourth one is about unknown state space problems. Here it's for exploring the problem state and the impact of actions are not known. For example, online search. Okay, we are keep on searching. We are trying to search something in the online. It's unknown state space problems. Then the problem characteristics of AIS 7 points. One is the problem decomposable? Can solution steps be ignored or undone? Is the universe predictable? Is a good solution absolute or relative? Is the solution a state or a path? What is the role of knowledge? Does the task require interaction with a person? We'll see one by one. The first one is about is the problem decomposable. Suppose for example the block world problem. We are going to solve this block world problem. Here this is about the starting state. This is a goal state we are expecting. Here the blocks A, B, C are on the table. We have a robot arm. Okay, here the initial state is described like on top of table we have B, on top of table we have A, on top of A we have the C. Then the hand robot arm is empty. Then there is no block on top of C and B on clear C and clear B. Okay. So here how do you make, what about the number of steps we have to reach this final solution, the goal? The goal it's described like on table. On table we have C, on top of C we have B, on top of B we have A, and A is clear, the hand is empty. Okay, here this problem can be done. If this can be decomposed, this can be done one by one. So whether the problem is here, simple problem we have block worlds. Here we have set of rules or preconditions. We can go for this adding, deleting the list. Okay, so here if you have any problem, just think whether this can be decomposable or the solution of the problem can be ignored or undone. For example, 8 queens problem, 8 puzzle problem. The 8 puzzle problem, once you done anything wrong, if you want you can undone the problem. Is it possible? This is your start state of your 8 puzzle problem and this is the goal state you are expecting. Okay, here in this we can say whether the solution can be ignored or we can undone the problem. Then example ignorable cases, the theorem proving case, recurable 8 puzzles, irrecurable example chess. The third characteristics of a problem is the universe predictable. Then certain outcome. Here 8 puzzle you can expect this is the outcome. Some cases we cannot go for finding that outcome of this game. Example play bridge. So certain outcome in the sense that guarantees one solution but uncertain we cannot say. Then fourth characteristic is a good solution absolute or relative. Okay, absolute that's a defined or may be different on time to time. Example TSP, traveling salesman problem. The fifth one is about is the solution as a state or a path. Whatever the solution you are expecting, maybe in terms of state or in terms of path. Okay, the traveling salesman we are finding the path from start to that, covering all the cities and reaching that starting position. Here the solution is a path. Then sometimes here the state in the sense the water jug problem. The water jug problem we have 4 gallons of um, jug and 3 gallon jug. Okay, here we are going to maintain 2 gallons of water in the 4 gallon jug without any measuring cup. So here the state of the jug is here. Here the solution is a state, then traveling salesman problem, the solution is path. Then what is the role of knowledge? Whether we have enough knowledge to solve the problem required to solve the problem, maybe reading newspapers or some experts in a particular area. So whether we need the knowledge or minimum knowledge is required to solve the problems. Then the last one is, does the task require interaction with the person? Whether we need to have this experts to solve the problem. So these are the various problem characteristics we have. The next one is about problem space and search. Here problem, a space of all possible configurations where each configuration is called a state. Initial state, goal state. Okay, here for a description, the formal, if you have a problem, how do you describe that scenario of the problem? Maybe in terms of starting state, goal state, then what are the intermediate steps. For example, take this monkey banana problem. Here, the monkey banana problem, here the monkey is in a cage and bananas are suspended from the ceiling. The monkey wants to eat banana but cannot reach them. Then in the room are a chair and a stick. If the monkey stands on a chair and waves a stick, he can knock a banana down to eat it. What are the actions the monkey should take? Here, monkey, stick and banana in the ceiling. Definitely from floor, the monkey cannot reach this banana. So he has to climb this chair. With stick, he can get this banana. How do you describe this in scene? This can be described with initial state, monkey on ground with empty hand, bananas are suspended. The goal state, monkey eating. The actions, climb the chair, grab X, wave X, X is nothing but that stick. Here grab X, wave X and eat banana here. The steps, monkey on the ground with empty hands, climbing chair without the stick, it cannot get banana, then again go back, then grab the stick from the floor, climb the chair, then wave the stick, then bananas fall to the ground, then get off chair, monkey on the ground with bananas, eating bananas. This way we can describe the problems with initial state, goal state, actions and some descriptions. We'll see some examples of toy problems. Here vacuum cleaner problem. Here if particular tile is dirty then check, otherwise if you are in A can go to the right for reaching the tile B, or if you are in B you can go to the left for reaching this A. Then tic-tac-toe problem, here it's also called knots. Here the cross is, there are two players here, one is using cross, other one is using the symbol O. We have 3 by 3 grid. Okay, if any person the X or O is getting 3 consecutive marks in horizontal, vertical or diagonal are formed, then the player who wants this. Okay, example here 3x here, then 3x like that. They keep on playing. They start with that empty 3 by 3 grid. Then either X or O is playing. They are taking their chance. Then if anyone is getting 3 consecutive X or O's in diagonal or horizontal or vertical, they won the game. This is about tic-tac-toe problem. Then second is about missionaries and cannibals problem. The 3 missionaries and 3 cannibals find themselves on one side of a river. They would like to get to the other side, but the missionaries are not sure what else the cannibals agreed to. The cannibals is nothing but man-eater. So the missionaries managed to trip across the river in such a way that the number of missionaries on the either side of the river is never less than the number of cannibals who are on the same side. The only boat available holds only two at a time. How can everyone get across the river without the missionaries risking the being eaten? So here three missionaries and three cannibals, one boat. They have to all six. They have to move from left one side of the river to the other side using a single boat. The man-eater will eat the man when the number of cannibals are more than the number of missionaries. This is the scenario given. Here, the assumptions number of cannibals should lesser than the missionaries on either side. Only one boat is available to travel. Only one or maximum of two people can go into the boat at a time. All the six have to cross the river from the bank. There is no restriction on number of trips that can be made to reach the goal. Both the missionaries and cannibals can row the boat. With this scenario, we can follow some rules here. Rule 1, starting we can go with one missionary saying the boat from bank 1 to bank 2. Then the final solution will be like initially we one river bank 1 we have this 3 missionaries, 3 cannibals. Then river bank 2 0. The next time one missionary, one cannibalist moving from this river bank 1 to the 2. Again the missionaries coming back to the river bank 1. Now we have 3 missionaries and 2 cannibals. So more number of missionaries than cannibals. So cannibals will not eat the missionaries. Again they are sending 2 cannibals to the next side. Again one is coming back. Then they are sending 2 missionaries to this one. Here 2 cannibals and 2 missionaries equal. Again they are sending one cannibal and one missionaries here. Then they are sending 2 missionaries here, one cannibal 3, so it will not eat. Now again they are sending this C here. Then all are reaching this step. So here all this 3 missionaries and 3 cannibals reaching this river bank 2 without losing anybody. This is a solution of missionaries and cannibals problem. The real world problem example is traveling salesman problem. Here we have a graph connected with all edges. The person has to start from one, listing all cities with minimum cost and should come back to that starting place. Here keep on trying with the states, different states. We'll find the solution. Thank you.